Climate change could kill thousands of Americans and cost the U.S. economy hundreds of billions of dollars.
The planet is now 1.1 degrees Celsius warmer than it was before industrialization.
The team says that a prolonged heat wave in the Siberian Arctic this year is unequivocal evidence of climate change.
And then, of course, the glaciers melting, as we pointed out, rising sea levels, and that impacts far beyond Alaska.
One of the worst storms that has ever hit Atlantic City.
Wildfires are scorching the West Coast, leaving behind a path of death and destruction.
The Amazon forests are burning at a record-breaking pace.
Thousands of people are displaced from their homes, feeling the immediate effects of the devastating climate events we're seeing these days.
We consider planet Earth to be our home, but we are the ones that are causing the death of it. The Earth is warming to temperatures never seen before, causing a massive change to the climate.
So we're absolutely certain that climate change is happening, and we're absolutely certain that it's to do with people, humans. And we know that from records of the past. What we're doing is we are putting in CO2 into the atmosphere at about 200 times the rate which nature did by 10,000, 20,000 years ago. And so there is a strong argument that the rates of change of sea level and temperature are far higher now than probably they ever have been in the geological record.
Climate change is happening now, and we can see the consequences clearly. However, we refuse to change our ways and continue to act like parasites by emitting insurmountable amounts of greenhouse gases into the atmosphere, primarily through our burning of fossil fuels.
And we see the effects everywhere. We see the effects in terms of warming, and the Arctic, for example, is warming at twice the rate of the rest of the planet, and for good reasons to understand why that might be, but also in extreme weather. And there is so many examples of extreme heat events, like in the Arctic, where we had 38 degrees of warming earlier this summer, and extreme rainfall events and extreme storm events, which you see in the United States through wildfires, through flooding, and hurricanes, but we see it all over the world as well.
Scientists around the globe are also extremely certain that humans are responsible for this change in the climate, especially through our burning of fossil fuels.
We are very sure that we are causing this change, and we know that because we measure many things that we see on our planet, and from that we can derive that it's us, that it's human activities that cause this change. To give you a few examples of how we know that. For example, we know that carbon dioxide in the atmosphere is increasing, and that could be both from human activities or from natural sources. But we also measure other things. For example, we measure that the amount of oxygen that goes down in the atmosphere, or that decreases in the atmosphere, is exactly the same amount of oxygen that would be needed to burn all the fossil fuels that would result in the CO2 increase. So that really suggests that the CO2 increase in the atmosphere is because of the burning of fossil fuels.
It's true that there's always been fluctuations in climate, but it depends how you're defining your climate, right, and what time scale. So the first argument about that has to do with the time scales involved. So it's true that there's been large fluctuations in average global temperatures through Earth history, like 4 billion years, right? But humans have really only existed. Homo sapiens has only developed in the last 200,000 years. So it's really the last 200,000 years that we should really worry about. And in the last 200,000 years, we did have major fluctuation. It's an epoch called the Pleistocene, by the way, and that's characterized by glacial, interglacial cycles. And so if we look over that period, turns out that today is warmer than any other time in the last 200,000 years, actually warmer than any time in the last million years or more. And so if we compare it to what's actually relevant to our human existence, it is like the warmest period.
By using large amounts of fossil fuels such as oil and coal, the global amount of CO2 produced annually is 32.5 billion metric tons, while the US alone produces 5.1 billion metric tons. Coal and oil are mainly formed from small plants and algae and are mostly made of carbon. When the coal is burned, the carbon reacts with oxygen to form carbon dioxide. That is released back into the atmosphere, adding more greenhouse gases. Carbon dioxide is one of the many greenhouse gases that exist naturally. Energy and heat from the sun can pass through the carbon dioxide in the atmosphere. However, carbon dioxide traps this energy when it gets reflected from the surface of the planet because it radiates back out as infrared light.
So to understand the carbon dioxide and the way the molecule works is that it can absorb heat at a certain wavelength and frequency.
Essentially, you're trapping radiation between the Earth's surface and the atmosphere. So you have like a feedback there, and you're trapping more energy there. The energy that you get from space has to radiate back out, right? There's a balance in energy. But what we're doing when we add CO2 in the air, the CO2 molecule actually is able to absorb some of that infrared radiation that the Earth emits back, right? So essentially, what's happening when you add CO2 in the atmosphere, it's like putting a blanket of the Earth where you're preventing the radiation from escaping right away.
In trace amounts, greenhouse gases are harmless and keeps the Earth from freezing. However, excessive amounts of greenhouse gases are extremely dangerous to our planet since they trap more and more heat, resulting in climate change and global warming. The current concentration is higher than it has been for 800,000 years.
We started burning fossil fuels literally at an industrial scale, and the level of CO2 started to go up. At the same time, so did the temperature of the planet. So the level of CO2 now is over 410 parts per million, and we are already more than 1 degree centigrade globally warmer than we were in 1850. So CO2, being the driver of climate change, has already, over just a short scale of 100 or so years, started that, and temperatures going up as a consequence.
The other thing that we know for sure is the fact that we are able to count how much carbon we emit, right? We know how much fuel we burn because we buy fuel and we extract it, so therefore we know exactly how much we burn. So there's very accurate accounting of where the carbon goes. So we know how much we emit, we know how much is in the atmosphere, how much is in the ocean, and how much is on land. So we have a very good understanding of that.
Even more surprising is that the amount of carbon dioxide recorded in the atmosphere does not match the amount of carbon dioxide we emit. The increase in the atmosphere is only about 50% of what we're putting in. This means that we're actually emitting way more carbon dioxide than what's recorded.
I just want to highlight that we are also lucky because not all the feedbacks that we know are reinforcing. Many of them are actually dampening and make sure that we don't see as much climate change or global warming as there could be. So the amount of carbon dioxide that currently remains in the atmosphere is around 40%. When we emit carbon dioxide into the atmosphere, basically we use the atmosphere a bit as a waste dump. We just dump our waste gases in the atmosphere. Actually, not all of the carbon dioxide that we put in the atmosphere stays in the atmosphere. Some of it is taken up by the biosphere, by the land, and some of it is taken up in the ocean.
Forests are a big part of the climate machine, and they help us a lot. Trees absorb 25% of the CO2 that we put into the atmosphere, removing and storing the carbon while releasing oxygen back into the air. In 1 year, an acre of mature trees absorbs the same amount of CO2 produced while you drive your car for 26,000 miles. Without forests, we would actually be in a more precarious situation, making our atmosphere even more hotter. Even though trees help mitigate global warming and climate change, we cut down 3.5 billion to 7 billion trees in 1 day. The Amazon, Congo Basin, and Atlantic Forest are just a couple of examples.
If the forest gets ravaged every year or every 3 or 4 years, it won't be accumulating the carbon dioxide that we hope it would be taking up from the atmosphere.
The oceans are also absorbing heat from the planet due to convection. Astoundingly, 93% of the heat that we put into the atmosphere is soaked up by our oceans. Convection happens since the surface of the ocean is warmer, while the deeper parts of the ocean are extremely cold and has not been exposed to the atmosphere for a long time. This deep, cold water then rises to the surface, soaking up more heat from the atmosphere. Over the last 30 years, the oceans have heated up to a half a degree Fahrenheit.
And so the planet does us an amazing service in being able to soak up roughly half of what we emit. But that can't continue because that's leading to ocean acidification. And the plants can only absorb so much carbon dioxide, and so there's a limit to what they can do. And what you can end up with is a runaway effect, that once that limit is reached and the oceans become saturated in carbon dioxide and can't emit anymore, then actually all the extra stuff goes into the atmosphere. And then you get runaway effect, because then we do see much more CO2 that we are emitting getting absorbed into the atmosphere, and much more global warming as a consequence.
The ability of the ocean to suck that CO2 from the air into the ocean depends on the gradient in CO2 between the air and the water. And so if you're increasing the CO2 in the ocean, you're actually diminishing the ability of the ocean to suck more CO2 later on. By acidifying the ocean, another consequence of acidification is to affect the air-sea CO2 exchange, and therefore the ocean becomes a less strong sink of CO2. So you're making your atmospheric CO2 problem worse.
If a lot of the heat stored by the oceans is put back into the atmosphere, it would heat up to 20 degrees Fahrenheit. This comes with consequences, however, since large amounts of carbon dioxide in the oceans is extremely detrimental to coral reefs and life in the sea. Coral reefs support about 25% of all life in the sea. We have lost 50% of the reefs in the last 30 years.
Coral reefs are also in danger through bleaching because of warming temperatures, acidification as well. And these are places where large numbers of marine animals survive too. So these are all well understood, they're all measurable, and our measurements tell us that the biodiversity in our oceans is decreasing as a consequence of all these things that we know we are doing to the ocean. We're very confident that human-induced climate change has an effect on the ocean that is detrimental to biodiversity within it.
When carbon dioxide is absorbed by seawater, chemical reactions occur that reduce seawater pH, making the ocean more acidic. The majority of sea life cannot handle such a drastic change in pH and die off as a result. Ocean acidification also reduces the amount of carbonate, which is a key building block in seawater.
It turns out that acidity, what we say something is acid, has to do with the relation with how much proton there is. So that's related to the pH. And so when we're dissolving CO2, we're changing the pH. And so if you put more protons, you have organisms in the sea whose shells are formed from calcium carbonate. And so when you have more protons, it means that the carbonate ion, so that CO2- can react with that proton to form bicarbonate. So you're basically taking away a carbonate ion that an organism actually needs to create a hard shell, a calcium carbonate shell. And these organisms are algae that float around, like little plankton, foraminifera, for example. But of course also coral reefs, right? Coral reefs are made of calcium carbonate.
The coral reefs are really like the hotspot in biodiversity for the oceans. This is where the largest amount of animals of different species is concentrated. This is definitely a warning that we should not just be looking at what remains in the atmosphere, because also the carbon dioxide that goes into the ocean causes acidification, and thus is also not harmless. It's not a service that comes without any trade-off.
This shows that when you change one aspect of the climate machine, you affect the others. This brings us to our next point. Not only is excess heat damaging the oceans, it is also damaging the polar ice caps. Due to the warming oceans and the warming atmosphere, colossal amounts of icebergs from the poles are calving and floating out to sea, where they slowly melt and make sea levels rise. Warmer air melts the top of the glacier, while warmer water melt the bottom of the glacier, destabilizing it and causing it to fracture. For example, in 2015, an iceberg called B-34 fractured from West Antarctica. Due to our actions, glaciers are retreating and melting, with oceans rising as a consequence.
So the big issue with the big polar ice sheets is global sea level. And we know that when the temperatures go up, ice melts and the sea level goes up as a consequence. But if you have a situation where naturally the level of the ocean is a metre higher than it ever would be normally, it just stands to reason and it's obvious that there will be more flooding as a consequence of that, and the flooding that you get will be more severe. And that's what we're starting to see. More extreme rainfall events, hurricanes starting to hit on land, flooding that results from that. But it's a coagulation of all those different processes. The low pressure, the tide events, the amount of water that's trying to get off, the winds acting in addition to rising sea levels through the ice sheet melt.
Now, if we melt glacier ice, so that we land ice, that represents water that's currently trapped on land to be put in the ocean. And so that actually creates sea level rise. You basically increase the amount of water in your bathtub, right? And so eventually it goes up.
If we do not resolve this dilemma, the seas could rise up 20 to 30 feet higher than today. The melting of the poles would have devastating results.
But actually underneath the sea ice and on the sea ice, there's lots of ecosystems, lots of species that are dependent on this ice being there over multiple years. And this goes from the big mammals, like polar bears or even seals, to, for example, small algae that grow under the sea ice and that also provide kind of breeding grounds or reproduction grounds for certain fish species.
There's so much ice in Antarctica and Greenland that if they all melted, all of it melted, there'd be something like 60 meters of sea level rise.
The ocean would flood major coastal cities around the globe, such as Venice, New York, London, Istanbul, and Hong Kong.
Billion people living close to the ocean, well, they'll have to go somewhere. All the cities and infrastructure that we have in these places, they'll be useless. So, the way that we inhabit the planet will have to change.
What's even worse is that the effects of climate change accelerate climate change itself, becoming an everlasting cycle. When the oceans heat up, the ocean releases some of the carbon dioxide it absorbed, since liquids hold less gas when the temperature goes up. This in turn causes the planet to heat up more, prompting a repeat of the same cycle. Another example of this everlasting cycle is shown through the loss of ice. The loss of ice causes the planet to warm further, since the polar ice caps reflect heat off of the planet.
But the other aspect, which is actually even more worrying, I think, is the concept of ice albedo feedback. So it turns out that some fraction of that visible light that's hitting the Earth is being reflected back to space by ice, by sea ice actually, and clouds. So by anything that's white, essentially, right? It's like a mirror. And so if you start melting sea ice, you're decreasing the size of the mirror that's reflecting energy back to space.
That white reflective surface is replaced by a dark surface, and that dark surface could be the land or it could be the ocean. Doesn't matter, because when the sun hits that surface, the energy gets absorbed within it, and all of a sudden that heat is now contained within the Earth rather than bounce back out into space. And what that delivers is more warming. So the more warming you get, the less snow and ice there is, and the greater the ability that the Earth has to retain more heat from the sun, and so on.
In addition to sea levels rising, the loss of sea life and the poles melting, climate change is also increasing the probability of certain types of extreme weather events. 7 of the 10 hottest years in history have occurred in the last decade, causing frequent droughts and wildfires, as we have seen in California and Australia.
Depending on how we manage forests, this biomass can accumulate a lot, and if it then gets very, very warm and very dry, which is caused by climate change, then this fire becomes much harder, much intenser, and it just destroys the entire forest.
We begin tonight with millions of Americans in the path of multiple natural disasters. That deadly wildfire emergency in California, and now the extraordinary double hurricane threat along the Gulf Coast. Some in the Florida Keys already told to evacuate.
Hurricanes, such as Hurricane Laura and Hurricane Harvey, are also becoming more numerous due to warmer waters caused by climate change.
Climate records that should be sort of 1 in 100-year type events are becoming more regular, more like 1 in 10-year, 1 in 5-year events. And that is totally understandable, predictable, and predicted from a climate change perspective. As the world gets warmer, the type of weather we will receive on the planet will be more extreme, more warm weather, more extreme downfall, rainfall events, and that's exactly what we've been experiencing. The problem is, it's going to continue unless we do something about it. And the real danger is to understand how that's going to continue in the decades ahead. It's already got bad, and we can see that for ourselves, but it can get a lot worse unless we take action now.
The evidence suggests that what we are going to see is more intense hurricanes. The formation of hurricane also depends on the genesis aspect. So hurricanes that hit the Gulf of Mexico are created in the Atlantic, right, towards Africa. And they are created by some instabilities that form in the atmosphere. And so once the instability forms, it spins a storm, essentially. And that storm can or cannot develop into a hurricane. Most of the energy that the storms take it from the ocean. So a warmer ocean means that once the storm is formed, it's got more energy to play with. But generally speaking, a warmer atmosphere can hold more moisture. And that means that that moisture has to come from somewhere. If you have warmer air above ground, the moisture that's in the ground can evaporate into the air, right? And so essentially, the places that are drier, that are already dry, essentially will become more dry, and places that experience a lot of precipitation will become more wet, because essentially the air, if it sucks more moisture from places where there's evaporation, that extra humidity will be moved to places where there's precipitation, and therefore there will be extra precipitation there. So what we're going to see is kind of an amplification of the hydrological cycle. So like water will sort of evaporate more and precipitate more.
Hurricane Maria slamming into the island, and as you heard, one official saying the island is destroyed.
Scientists have predicted that in 100 years, the Earth will be 5 to 10 degrees hotter. These are the devastating consequences that will take hold if we do not prioritize global warming as a major dilemma.
Understanding the climate problem now and doing something about it will save future generations having to deal with the impossible situation of rising seas that they can't do anything about. Because once you're kind of locked into it, once the ice sheet starts to change, it's already too late by that stage. It's not too late now. We can do some things about it. There are some issues that we are locked into. Sea level rise will go up in the next 80 or so years. But the question is whether we can restrict it to, say, 0.5 meter, or whether it goes more than 1 meter and then much more than that beyond the century. we have an obligation to those who come after us not to make the condition of the planet uninhabitable for them. We know this is a problem. It's our problem. We've created it. But we're the first generation, the only people that know that we can do something about it. And we also know the longer we leave it, the more difficult it is to find those solutions. So the time for action is right now. The next question is, once you get all that out of the way, okay, what do we do about it? And that is the question. And there's no easy answer. Right? There's no silver bullet. There's no one thing you can do that's going to change everything. It needs concerted effort from virtually every aspect of our society and the way that we currently live on this planet. Because the way that we live on this planet at the moment is causing a real problem for the climate, and it's not going to allow us to inhabit this planet in the way that we want to for future generations. It's not to say that humans will become extinct. That's not going to happen. But the way that we live on this planet won't be possible in 100 years if we just keep going the way that we're doing.
It is not too late to avert this crisis, but we have to start acting now. Climate change is not a dilemma in the future. It is something that is happening now.
The good news is we can do things about it. We know we can electrify our power system. We know we can think about transport and heating and manufacturing and food production, and all those things we can do in a much lower carbon / zero carbon way. And there are plans taking place to do it. But it needs more than just some wishful thinking. It needs action.
It's our choice whether in 2050 we will be living in a better world or in one that is really dominated by climate change and by extreme events and by disruption.
What gives me hope is that technology has improved dramatically over the last decade, to the point that we have technologies like solar panels and wind turbines to help combat climate change. To combat climate change, scientists have also developed carbon capturing technologies to decrease the amount of CO2 in the atmosphere, with the intent of reaching negative emissions.
There's also possibilities to actually develop things that we call carbon capture and storage, which is a technology that still is not really existing, right? That's something that people are trying to develop. So it's maybe, I don't know if you want to bet a future on a hypothetical technology, but it's the ability to suck CO2 out of the energy production system directly and re-inject that CO2 into the reservoir that from where we got the fossil fuel from, essentially.
We should first and foremost reduce the amount of emissions that we are producing, but at the same time, this carbon dioxide removal or these negative emissions can help us to get to net zero, and then afterwards they can also help us to slowly reverse warming if we think that where we ended up is not a safe place.
In addition to creating new technologies to mitigate climate change, we also have to demand that our governments start taking action by passing policies that are beneficial to our planet.
And it needs action from sort of three sectors, I would say. The first, of course, is government, and they need to make decisions about committing to a lower carbon future and then applying taxation and spending in the right way to encourage that to happen. And that's what the Paris 2015 climate agreement is all about. And we're seeing countries all around the world. Today, I learned that Japan is committing to zero carbon by 2050. The United Kingdom has already committed to zero carbon by 2050. China has committed to zero carbon by 2060. And there are others as well. And that's all very good news. So that's the first thing. Governments need to step up.
We are also announcing the Carbon Neutral Government Program that requires government organisations to be carbon neutral by 2025.
The difficulty with climate change and climate policy is that it is a very slow and long problem. Companies that make, or businesses that make investments and normally are only interested in what happens the next quarter or maybe the next year, they don't have this long-term vision of where they should be going and where they should be heading. And that is really where governments come in to indicate in 10, in 20 or in 30 years, this is where we have to end up. to solve this problem. And that is where government policies and government regulations are really important, to provide this long-term vision, and also in some cases to provide the security that we care today about climate change, we will care tomorrow about climate change, and in 10 years we will still care about climate change.
And most important thing to do is to reduce carbon emission, right? We know what the source of that problem is, and it's CO2 emission, burning of fossil fuel. Now, the ways you can try to deal with that there's multiple aspects of that. So there's a systemic change that has to be enacted sort of at the political level and industry level. And there's there are personal things that we can do to affect change ourselves, right? The first thing, of course, is to move our energy production system away from dirty fuels like coal into more renewable fuels like wind and solar.
Companies around the world also play a crucial part in alleviating climate change, as they manufacture most of the world's goods and are responsible for 71 to 80% of global emissions.
Business is in control, essentially, of our economy, of our fossil fuel-driven economy. And we need business to understand that their future has to be a zero-carbon one. And it's through their investments, their technology that they develop, that has to change in the decades coming. And more companies are now understanding that they want to change. They know the future has to be different to the past, and they want to do that. For example, with electric vehicles, who would have thought 10 years ago that electric cars would be so desirable? Now, how did that happen? It didn't happen because the government did it. It didn't happen because people chose it. It happened because of Elon Musk, who disrupted the car markets, made Tesla vehicles to be desirable, and everyone wants to do that. And now every single car manufacturer around the world has an electric vehicle plan. Well, they simply would not have done that if it hadn't been for Tesla starting off. So business can really make a difference.
Yeah, so I don't think it's true that many companies don't want to change. I would say that most companies nowadays have accepted that it is a problem, and in fact an urgent problem, and so they're trying to tackle it. I would even go further and to say that unless you are now, as a company, committed to doing something against climate change, or actually try to mitigate its effect, you are going to become obsolete as a company very quickly. That basically means that you're going to be out-competed. You're selling obsolete technology. You can now achieve similar goals with much cleaner technology, which is actually also cheaper.
The actions of governments and companies are not enough, however. It is also up to all of us as individuals to solve this crisis by changing our lifestyles and reducing our carbon footprint.
The third sector is you and I. It's everybody on the planet. It's individuals. And we have to understand that our behavior, the way that we live on this planet, is a high carbon way of living, and we have to change that. And so we have to consume less. We're going to have to change our diets. We're going to have to take fewer flights, right? All those things are completely possible. It doesn't ruin your life, right? It makes things better.
The other thing you can do, of course, is change your habits as a human. So you can travel less, you can bike to places. Another thing we should really do is change the way our houses are built. We should insulate the houses so that we don't rely so much on heating or cooling, right?
If we were smart, we would have started trying to solve this 30 years ago in 1990 when the United Nations Framework Convention was adopted, and that was in 1992. But we didn't. Emissions still went up since then. So it is really urgent that we do this today. And of course, people are afraid that they have to change their lifestyles and change their lives. But lives and lifestyles are changing every time. We live very differently than we lived last century, and we will be living very differently in 2050 than we will be living today.
So that's the choice we've got, is either don't care about it and have to deal with these massive consequences in the future, or understand that this is a problem that's of our making and we can do something about it right now. But I see the start of things changing. I see governments falling into line and pledging zero carbon futures. I see companies doing it, and I see people really understand that this is a change that's necessary.
It is a planetary crisis, and it is a crisis that we have collectively created, which is why it is up to all of us to combat climate change, not just for our generation, but for future generations as well.